Hello students, welcome back to the fifth video of this playlist. So in this video, we will be solving question number 5 from January 2024 Pure Mathematics 2 paper. So let's see what's the question number 5 from this paper is about. So basically the concepts behind this question, that is question number 5, it's from uh, series and sequence and series that has been discussed in chapter number 5, that is chapter number 5 of your PO Mathematics 2 textbook. So in order to be able to solve this question, you should have definitely finished chapter number 5, and you should know the concepts from specifically sequences, how to deal with sequences, how to find out the summations, how to deal with uh, summation, yeah, sequences, these stuffs. So let's get started with question number 5. Okay, part 1, find the value of what? Summation of summation to 6 times 0.25 to the power r from r equals to 1 from the first term till infinity. So we need sum up to infinity. So 6 times 0.25 to the power r. So from the equation you can understand that this is basically a geometric what? Sequence. Okay, with common ratio which is 0.25. Okay, so for part 1 we got the common ratio r is equals to how much? 0.25. Okay, so summation to what? Infinity. Okay, so sum up to infinity, that would be what? The first term is what? A over 1 minus r. A over 1 minus r. Sorry, this is the summation of the up to infinity. The equation for the summation up to infinity is a over 1 minus r. So we need a. So a is r equals to 1. When you put r equals to 1, what you will get? 6 times 0.25, which is 6 times 1 over 4, which is 3 over 2. So now just put the values there. 3 over 2 over 1 minus 0.25. Okay, so what would be the value for sum up to infinity? 1.5 divide what? 1 minus 0.25, which is 0.75. This is basically 2. That's the answer for part 1 of question number 5. That's it. Okay, next is part 2. A sequence u1, u2, u3 is defined by u1 is 3, u of n plus 1 equals to u of n minus 3 over u of n minus 2, where n element what? This is called natural numbers. Okay, part A asks here to show that this sequence is periodic. Periodic means what? The sequence is getting repeated after a certain some certain terms. Okay, so to show that it's periodic, we need to find out the first term, the second term, and so on, and we will look for whether any term is getting repeated or not. Okay, so for part 2a, at first find u1 is given. U1 is given as how much? U1 is 3. So u2 would be, what would be u2? U2 would be u1 minus 3, right? U1 minus 3 over u1 minus 2, if I'm not wrong. U1 minus 3, yeah. So 3 minus 3, u1 is 3, so 3 minus 2, which is 1, which is just 0. So u2 is what? U2 is 0. Let's find u3. U3 is what? U2 minus 3 over u2 minus 2. So u2 is what? 0. So 0 minus 3 over 0 minus 2, which is 3 over 2. Okay, so we got u3, this is 3 over 2. Now u4. u4 is what? u4 is u3 minus 3 over u3 minus 2. So u3 is what? 3 over 2. 3 over 2 minus 3 over 3 over 2 minus 2. Okay, so you'll get negative 3 over 2 over 1.5 minus 2. This is negative half. So you will get negative negative cancels out. So 3 over 2 times 2, this is 3, which is equal to what? u1. Fine. That means after each 3 terms, the what? This sequence is getting repeated. Okay. So this is for how much marks? 2 marks. Okay. So hence, what we can say? The sequence is periodic. The sequence is periodic of order what? Mention the order. We got okay. State the order. State the order. Order has been asked in the next part. Okay. So hence the sequence is periodic. Why? Since e1 is equals to what? u4. That's why. Okay. So that's what they wanted in part 2a. Okay. Next in part b, the question is asking to state the order of this sequence. So from part A, we figured out the sequence is what? Periodic. And we also know that the sequence has a period. What? How up like period is how can we determine the period? Period is dependent on like after how many terms the the sequence is getting repeated. So this is what we got u1 equals to u4 earlier in part A, right? So that means the difference from u1 to u4 is what? 3. So this is order 3. The sequence has order what? 3. That's it. Okay. Next is part C. Part C asks to find, hence find, that means we need to use the ideas from part A, part B. Okay. We need to use the concept, the answers that we have found in part A and B to find the summation of u of n from n equals to 1 to what? 70. Okay. So we need to find out the summation. So we know that this sequence is periodic, isn't it? So since the sequence is periodic from n equals to 1 to 70 u of n. So since the sequence is periodic with period of order 3, that means we need to consider from n equals to 1 to 70 how many periods will be there. Okay, so 3 times 20, this is 60. So 23 is what? 69. Okay, so that means there will be 23 periods. Okay, since there are 23 periods, so there will be uh, what are the numbers of this sequence? u1 is 3, u2 is 0, and u4 u2 is 0, u3 is 3 over 2, u1 is 3, u2 is 0, u3 is 3 over 2. Okay, this is the numbers of the sequence 3, 0, and 3 over 2. So ignore 0 since 0 has no values. So 3 and 3 over 2. Okay, so there will be exactly 23 what? Periods. So 23 threes, and then there will be how many? 23 3 over 2's, right? Okay, so 23 times 3, we got 69 terms. So what would be the last term? The 70th term. The 70th term will be the first term of the sequence because 69 terms makes complete sequence, complete period, completes the period. So the next term, that is the 70th term, would be the first term of the sequence, which is nothing but 3. Okay, so 23 times 3 plus what? 3 over 2 times 23 plus 3. So this is 213 over 2. 213 over 2. This is the summation for u of n from n equals to 1 to 70, and that's what the question 5C has asked for. And that's the end of question number 5 from January 2024 Pure Mathematics 2 paper.